Okay, this is our video for the last lesson in Chapter 5. This is 5.8 Factor Linear Expressions. And the first note that I want you to take down says, when factoring linear expressions, we divide by the GCF of all the terms. So what you need to do is copy GCF in the blank in your notes. Just to review, GCF stands for greatest common factor. So we're going to be doing the GCF today in our problems, and that's actually where I want to begin first. I want you to note this is not a problem in your notes, so I just want you to sit tight, watch, listen, and learn how we do the GCF in 7th grade. So in 6th grade, you found GCF. You probably only did GCF for numeric terms, like 18 and 45. In 7th grade, we now are finding the GCF of algebraic terms. So I want you to take note. We have 45x squared y and 18x, and we want to know the greatest factor that we can divide out of both of those terms. So to begin, we focus on the coefficients. 45 and 18, we need to find the GCF of those two numbers. You can do this by listing the factors or even using a factor tree. I don't care how you do it, as long as you arrive at the number 9. 9 is the greatest number that can divide into 45 and also into 18. So that's our GCF of the coefficients. Next, we look at the variable parts. I want to take a look at x squared y and I want to expand it. I want to write it out not in exponential form. So x squared y means x times y. I want to do the same thing to this term, and it's a lot simpler of a variable piece. It's just a lonely x. So to find the GCF of the variable parts, I look for the number or the variable that shows up in both terms. And that's 1x here and 1x here. So I take my x, I write it with my 9, and that tells me that the GCF of both of those terms is 9x. That means I can divide 45x squared y by 9x. I can also divide 18x by 9x, and it'll work out evenly. Here's an example in your notes. This is number 4. It says to find the GCF of 40xy and 36xy. We're going to start the same way. 40 and 36. We're going to focus on the coefficients. I don't care how you find the GCF of the coefficients, if it's listing or with a factor tree, but I know, and I hope that you can figure out, that 4 is the GCF of 40 and 36. It's the largest number that can divide into both of them. Now we take our variable parts and we expand them. xy means x times y. Over here, a little simpler piece, we just end up with a y. What's common to both variable parts is the y, so we write it down below. Our GCF of those two terms is 4y, so each term can be divided by 4y. Number 5 you're going to do as well. If you want to pause the video now and do number 5, that might be a good idea. If not, remember to finish that one up tonight for homework. Factoring expressions. So we're talking about this GCF, and we're talking about factoring an expression. This is not in your notes, so just sit back and pay attention. To factor means that we want to take this expression and we want to write it as a multiplication problem. We actually want it to look like a problem where we would distribute it. We would use the distributive property to simplify it. So what we do is we look at our two terms and we find the GCF. So the first thing I notice is that there's an m in the first term but not an m in the second term. So the GCF will not contain any variables. Now I'm looking at my numeric part, 36 and 18. So the GCF of 36 and 18, if you don't know what that is, you can certainly make a list, or you can list all the factors. We can do a factor tree, whatever is easiest. But the GCF of those two numbers is 18. So we are going to put the 18 on the outside of the parentheses. Now, we are going to divide both terms by 18. 36m divided by 18. Well, 36 divided by 18 is 2. So that's 2m. And positive 18 divided by positive 18 is a positive 1. So our factored answer, factored expression for 36m plus 18, we've divided the GCF out of both terms, and it is 18 times the quantity of 2m plus 1. Now, if I wanted to, I could check my answer by redistributing the 18, and I should end up with 36m plus 18 because these two expressions mean the exact same thing. This is a problem that's from your notes. This one's a little bit on the trickier side, which is why I want to do this one with you instead of having you practice this one for homework tonight. So take a look at my two terms here. I've got negative 20x minus 30z. I hope you notice the first number is negative here. Whenever the first coefficient is negative, that means we want to divide a negative GCF out of there. Okay? So again, we start with the coefficients. I have my negative sign here. I can see that I've got a 20 and a 30 for my coefficients. So my GCF is 10. And I'm going to make it a negative 10 because the first term is negative. So the next thing that I do is I have to do my division. Negative 20x divided by negative 10. A negative divided by a negative is a positive. So that gets me a positive 2x inside the parentheses. Here, negative 30z divided by negative 10. A negative divided by a negative is a positive, so that gets me a plus sign in here. 30 divided by 10 is 3z. So my factored version of negative 20x minus 30z is negative 10 times the quantity of 2x plus 3z. If I wanted to, I could distribute the 10 back, and I will end up with my original linear expression. Let's see a word problem. Let's see why we do factoring in the first place. This says a rectangular garden has an area of 15m plus 9 square yards. Find one possible length and width of the garden. So my area of that garden is 15m plus 9 square yards. You know me, I like to draw a picture. I'm a visual learner, so I would draw a little rectangular garden here. What we can do is we can take this 15m plus 9 and we can find the GCF. Okay, so 15m plus 9, 15 and 9 is where I'm going to start. I know that I can divide a 3 out of both of those as my GCF. 15m divided by 3 is 5m. And positive 9 divided by positive 3 is positive 3. So here's how we can use that answer to answer my question. This is a little multiplication problem, and we know that area is a multiplication problem as well. Area is, you may have been taught length times width in 6th grade. In 7th grade, we do base times height. So either one you use is perfectly fine. But what this tells me is that my first factor is one of the side lengths, and my second factor, the one in parentheses, is the other side length of the rectangle. So to answer this question, we would say a possible length is 5m plus 3, and a possible width is 3. We could write that in a sentence. I just want to give you one note here. In my question, I specifically asked you for length and width. Sometimes in other questions, they may ask this differently by saying things like, what are the dimensions? The dimensions of the garden. If they ever ask you for the word dimensions, that means to find the length and the width. Okay? So we've done a lot of factoring today. Here's your assignment for tonight. You are going to finish number 1, number 2, and number 5 on page 6. You're also going to do 7 and 8 on page 7. Number 8 is the write your own question. Don't forget, I'm looking for a word problem if possible. These questions will show up on your Google form, so make sure you get that done. And don't forget to write down any questions you have about Chapter 5 because we are going to start reviewing for the Chapter 5 test in class tomorrow.